Dear students, in the last class we derived an equation for normal stress and shear stress on a particular plane, and in previous class we discussed an expression for derived an expression for this one principal stresses and principal planes. Till now, whatever we discussed in previous sections, they all were for general stress systems. General stress systems. General stress system means what? If a plane is like this and that will be subjected to many stresses. This is the normal stress in x direction and normal stress in y direction, and it will be having some shear stress also. If it has normal stress in x, normal stress in y and shear stress, then we will call this as general stress system. Based on availability of the sigma x, sigma y and tau xy, we can classify this compound stress into some categories. That first case 1 I will consider. Case 1. This case 1 I will call it as a uniaxial stress system. Uniaxial stress system. Uniaxial stress system means on this plane, on this point, only sigma x will be present. Sigma x will be present. Then sigma y and tau will be absent. That I can consider as sigma y, which is not given, not shown in the figure, that I can consider 0, and tau xy not given, not shown in the figure, that I can consider 0. Then you already know that sigma theta value. Sigma theta equal to what? I don't write here. Sigma x, we'll write it, no problem. Sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. In this equation, I don't have sigma y value. Sigma y value I don't have. Sigma y value I don't have. Tau xy value I don't have. Therefore, I got sigma x by 2 plus sigma x by 2 cos 2 theta. This becomes your sigma theta equation. Further, you can simplify this. Sigma x you can take common. 1 plus cos 2 theta by 2, you can write it this way. And this 1 plus cos 2 theta by 2 in trigonometry, you can call it as a cos square theta. See, this is your sigma theta value. Right? Then like that, tau theta value also you can get it. Tau theta is sigma x minus sigma y value, sigma x minus sigma by 2, sigma x minus sigma y by 2 into sin 2 theta minus tau xy cos 2 theta. Here what happens? This tau xy is 0, therefore this is gone. Then sigma y is also gone. Sigma x by 2 into sigma x by 2 into sin 2 theta. Right? This you can have. This sin 2 theta you can split it. Sigma x by 2. This is a 2 sin theta cos theta. Then again 2 to cancel. You can have like sigma x sin theta cos theta. What is this? This is tau theta value. Right? Means on any interested plane you can have sigma theta and tau theta. Those two values you got it. This one or this one. Okay. Then on uniaxial stress system, what is principal stress? Sigma 1 comma sigma 2 equal to sigma x plus sigma y by 2 plus or minus square root of sigma x minus sigma y by 2 whole square plus tau xy square. In this one, this is a general equation, general stress condition, but in this one it is not there. This is not there means this square and root cancels. Then this is also not there. Then this is also not there. Then what is left? Sigma x by 2 plus or minus sigma x by 2. Here also sigma x by 2 you got it. Once if you use a plus here, sigma x by 2 becomes sigma x. If you use a minus, the answer becomes 0. Therefore, sigma 1 value, major principal stress will be sigma x and minor principal stress value will be 0. You got it. The same thing on uniaxial stress system. Tau 1 and tau 2 if you want, plus or minus square root of This is the general stress system, sigma x by 2 whole square plus 2xy square. Here I don't have this one in uniaxial, and this square and root cancels, then sigma y is not given. Therefore, plus or minus sigma x by 2 is your answer. This is tau 1 comma tau 2. If you want tau 1, use plus sign, tau 2 for that minus sign over. Okay. Then if you want the orientation of principal plane, major principal plane, that equation I have tan 2 theta p1 equal to 2 tau xy divided by sigma x minus sigma y. In this case, sigma, this is not there and this is not there. Therefore, tan 2 theta p1 becomes 0 divided by sigma x. 0 by sigma x means 0. That is tan inverse, 2 theta p1 equal to tan inverse 0. That is 0. Therefore, theta p1 is 0. Then, theta p1 is 0 means theta p2 will be perpendicular to that. Therefore, theta p1 plus 90 degree. Therefore, 0 plus 90 degree is 90 degree. Then, theta s1 will be what? Theta s1 will be theta p1 plus 45 degree. Then, theta p1 is 0 plus 45 degree. Therefore, 45 degree. Like that. Theta s2 is what? Theta s2 is perpendicular to theta s1. Therefore, theta s1 plus 90 degree. Therefore, 45 plus 90 degree, that is 135 degree. This is all about uniaxial stress system. I can list out here. Uniaxial, case 1, uniaxial. Then what are those? Sigma theta is sigma x cos square theta. Tau theta is sigma x cos theta sin theta, and sigma 1 is sigma x, sigma 2 is sigma y, 0. Then tau 1 is sigma x by 2 and tau 2 is minus sigma x by 2. Then theta p1 is 0, theta p2 is 90, theta s1 is 45, theta s2 is 135. These are the data for case 1. Okay, now we'll go to the case 2. Case 2 is what? Yours biaxial stress system. Case 2, that is your biaxial. Biaxial means if a point is like this, only sigma x and sigma y will be there. Sigma x is there, sigma y is there. Okay, this is sigma y, sigma x. Then what is not there? Tau xy not there, not given, therefore 0. Therefore your tau theta, sigma theta formula, first sigma theta formula, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta. Here plus tau xy sin 2 theta, but this is not there. This is not there because tau xy is 0. Then what about this? This you got, and this is only the equation. This is sigma theta equation. Tau theta equation will be sigma x minus sigma y by 2 plus sin 2 theta minus tau xy cos 2 theta. Then again this is not there, therefore this is your equation. Then in the same case, sigma 1 comma sigma 2 will be sigma x plus sigma y by 2 plus or minus square root of sigma x minus sigma y by 2 whole square plus tau xy square. This is for general, but this is not there. This is not there means this square and root cancels. Therefore your equation will be sigma x plus sigma y by 2 plus or minus sigma x minus sigma y by 2. See here, if you use first plus and take LCM, then you will get sigma 1 value as sigma x, and use a minus, take LCM, then sigma 2 value will get sigma y value. Oh, these two are the things. Sigma 1, sigma 2, you got it. The same thing, shear stress if you want, tau 1 comma tau 2 equal to plus or minus square root of sigma x minus sigma y by 2 square plus tau xy square. This cancel because it's not there in the biaxial. Then this square and root cancels. Therefore, tau 1 comma tau 2 will be equal to plus or minus sigma x minus sigma y by 2. Use plus for tau 1, minus for tau 2 over. Then the orientation of principal planes are tan theta p1 equal to theta p1 equal to 2 tau xy divided by sigma x minus sigma y. But this is not there. Therefore, this becomes what? 0 divided by sigma x minus sigma y is nothing but 0. What is 0? Tan 2 theta p1 equal to 0. Therefore, 2 theta p1 equal to tan inverse 0 is 0. Theta p1 is also 0. P1 theta p1 is also 0 you got. Then theta p2 will be 90 degree, same as it is in the uniaxial stress system. Understood? Then the conclusion for case 2. The case 2 is your biaxial. Then sigma theta value will be sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta over. Then tau theta will be equal to sigma x minus sigma y by 2 sin 2 theta over. Then sigma 1 will be sigma x, sigma 2 will be sigma y. Then tau 1 and tau 2 will be sigma x plus sigma y by 2, but these are subjected to plus or minus. Okay. Then theta p1 is 0 again, theta p2 is 90 degree, theta s1 will be 45 degree, theta s2 will be 135 degree as it is. Okay. Now coming to the case 3. Case 3 I will call it as a pure shear case. Pure shear case means if a point is like this, no sigma x, no sigma y, only you will have a shear stress tau xy. Therefore, sigma x and sigma y both are 0. Then what will be the equation? Sigma theta value if I write, for general it is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. But these cancels because sigma x and sigma y both are not there. Therefore, sigma theta will be equal to tau xy sin 2 theta. Like that, tau theta will be equal to tau xy minus it is cos 2 theta because sigma x, sigma y are not there. Then coming to sigma 1 comma sigma 2 value will be sigma x plus, in general, sigma x plus sigma y by 2 plus or minus square root of sigma x minus sigma y by 2 whole square plus tau xy square. Then this is gone and this bracket is also gone. Therefore, square root cancels. Therefore, sigma 1 will be plus tau xy and sigma 2 will be minus tau xy. Okay. Now? Then going to the maximum shear stresses, then tau 1 comma tau 2 will be equal to plus or minus square root of, for general, sigma x minus sigma y by 2 whole square plus tau xy square. Then this is gone for pure shear, square root cancels. Therefore, tau 1 equal to tau xy and tau 2 is equal to minus tau xy. Then coming to the orientation of principal planes, that is tan 2 theta p1 equal to 2 tau xy divided by sigma x minus sigma y. This time the denominator is not there. Therefore, this becomes 2 tau xy divided by 0, that is your infinity. Then 2 theta p1 equal to tan inverse infinity. Tan inverse infinity is 90 degree. Therefore, theta p1 will be 45 degree. When theta p1 is known to you, then theta p2 will be 45 plus 90 degree because perpendicular to each other 135 degree. Then theta s1 will be equal to theta p1 plus 45 degree, therefore it is 90 degree. Then theta s2 will be equal perpendicular to theta s1, therefore 90 plus 90 is 180 degree. Over. Then the conclusion if you want to write, then for case 3 conclusion if you want to write for pure shear case, pure shear, that is tau sigma theta will be tau xy sin 2 theta and tau theta is tau xy minus cos 2 theta. Then sigma 1 will be tau xy, sigma 2 is also tau xy, but it is minus tau xy. Then tau 1 is tau xy, then tau 2 is also minus 2xy. Then theta p1 45 degree, theta p2 135 degree, theta s1 90 degree, theta s2 180 degree. Oh, these three cases are there, and these three cases if you know, then you can solve problems very easily. Right? Dear students, in next class we will solve problems on this chapter. Thank you very much.